chapter 10. If we have time, we will start chapter 12. Next week, we do not have class. I will be out of town. I will go to a conference, so I will be on for the whole week. But I will record videos for the next chapters. Okay? So I will post the videos probably during the weekend, Saturday or Friday to Facebook. So
it's a substitute class, Monday and Wednesday. Like you'll post videos covering what we will cover in class.
Yes. So you can watch the videos on Facebook. Okay? So that's for the next week, and I also posted chapter 10 and chapter 8 assignments and quizzes. So those activities will be due on November 12th. So we have about less than 2 weeks to work on those assignments. But for those two chapters, we don't have too many questions in your assignment. Okay? So that's all we have before the class. So last class, we talked about how to build a model in spreadsheet. So we built a model for decision-making problem, and in the problem, we want to decide, are we going to manufacture the product by ourselves or we purchase from a vendor? So that's the problem we have. We built a model, and also we did some what-if analysis. So the first analysis we did is the one-way data table what-if analysis. We changed that's the file I have. So we changed the quantity that we need. So what if we need 0 units, 25,000 up to 300,000 units? Then what's going to be the saving? So that's the analysis we did in the last class. So this is one application of what if analysis. So this one is to change the value of one variable. So what if we change two variables? We still change the quantity, and what if we have different price from our vendors? So in this application we only have one outsourcing cost per unit, $3.5. Okay? We only have one. What if I have more vendors that are interested in doing business with me? So one is, okay, we still have this vendor who proposed 3.5. What if I have more than one prices from the vendors? So that's going to be called two-way table what-if analysis. We change the value of two parameters. One is the quantity, so that's our determined variable. The other is the price, outsourcing price. Then we will see how the saving will be. Okay? So please open the file that we used last class. So that's the model we have. So please open the file. So we will continue to work on this. So let's create a new worksheet. So I just copy all the data here. I created a new worksheet, and then I copy the data from the previous one to this new one. Yeah. So that's the model we had. So we changed the quantity, so that is 1. So right now we want to change the value of another variable. Say, let's say we got different prices for the products from other vendors. So say 2.89, 3.3. Let's make up one more. 3. Okay, so let's make up 3 more prices. Let me delete this one. right now we have one column from the previous worksheet, and I added one row which shows different prices from different vendors. You want to compare different prices from different vendors and see what savings you can get. So we can still use what-if analysis in the Excel to calculate the saving based on different combinations of the values. But here we need to tell Excel file what value we want the function to calculate. So in here, we have three different prices, we have different quantities, and in this blank cell, let's tell the Excel we want to calculate the savings. So in my file, the saving is in cell B17. So in my file is B17, but you need to select the one on your worksheet. So let's tell cell that's the value we want. After you have this reference point, let's select the whole range to cover all the columns and all the rows in this area. So let's select the whole area. Then let's use the what-if analysis tool. What-if analysis, where it is? Okay, it's under Data tab, and we have a function called what-if analysis, and let's click on this data table, just like what we did in the last class. So right now, so last time we only gave one value for the column input cell, because we only changed one variable, the quantity. So in this application, we still want to calculate the quantity variable.
In the data analysis, which one?
What-if analysis. So under data tab, under data tab and what-if analysis. So the function, the what-if analysis function is not under the data analysis. It's a separate function. So it's right there, what-if analysis. So that's the function we're going to use. So the column cell. So mine is, I need to tell them, okay, the column is about the quantity, the different quantities. So in the, what's that called? So that's called column input cell. We still select the quantity. So in my file, the quantity is in B11, but your worksheet you need to select your own. And then the input cell, we need to tell the input cell as the outsourcing cost per unit, because we are going to give different values for the outsourcing cost. So let's tell Excel the row has different values for the outsourcing cost. So in my Excel, it's in B7. So we need to give two values. So after you have those two values, let's click OK. Then we will have the savings. So it shows the savings based on different combinations of the quantities that you need and the outsourcing price per unit. So let me repeat this real quick if you did not follow. So this is what we had. Let me delete. Not delete everything. Let me delete this one and this one. So this is the data we had from the last class. So I entered 3 different outsourcing prices. I want to see the savings based on different combinations of quantities and outsourcing price per unit. And I need to tell the first value. I need to tell the Excel is that I want you to calculate the savings. So in the intersection of the row and column, I need to tell Excel. You need to help me calculate the savings. So tell Excel the expression of calculating savings. So I select this cell. Okay. Then I select the whole range that I want the Excel to populate. Then we use this what if analysis tool under the data tab, data table that we used in the last class. And row input cell, I need to tell Excel the row has different values of outsourcing prices. So where is outsourcing price? Here is the price. And the column input, I need to tell Excel this is my quantity. It has different quantities. Then it will populate the whole area. That's it. You only need this part from A1 to you don't need the new prices, or you can just clean up those prices. Delete the quantity. Because saving select the whole area. Input cell So that's a two-way table analysis. Let's save this file. So we have this one, and that's what we had, but we use different numbers. So that was one application. One more application is goal seek. What value or what saving do we want to achieve? So for example, saving, you want to see, for example, if you want to know the break-even point, you need the quantity such that outsourcing and manufacturing by yourself have the same cost. So you need that quantity. Then your goal is to have the saving as there. So let's still use this file. So we don't have to touch this part. So let's use data, what if analysis. Let's still use one what if analysis. The function we are going to use right now is the goal seek. The second, I think that's going to be the second option. So there are 3 inputs we need to give. Set cell, which one to value, which one by changing which one. What does that mean? So set cell, so that is saving. Because we said we want the saving equal to 0. So we want set cell the saving to value of 0, because that's our goal. We want to see the saving of 0 by changing our quantity. So the third one will be our quantity.
What was the second?
So which one? The third one or the second one? Second one is 0, because our goal is to find the quantity such that the saving is 0, or the manufacturing cost and outsourcing costs are equal. Okay. Now we have one. So you will see after you click OK, you will see the numbers are updating, and this quantity is the break-even point. So this is the quantity that makes the manufacturing and outsourcing cost cheaper. So that's the goal thing. If you wanna set another goal, that's also fine. You see, say if you wanna achieve a saving of $10,000 or $1,000, you can just change 0 to 1,000 or whatever number you wanna see. So any questions on this application? Go see. Okay, scenario manager. So that's the third function of the what if analysis tool. So scenario manager, in the scenario manager, we can set different combinations of different parameters. So we have to define the parameters such that we can have a scenario. So defining one scenario may require like 3, 4 different values of parameters. So using one-way or two-way table, that's not going to be enough. So we need to we need to use the scenario manager. So let's download the Excel file called Middletown Amusement. I think the file name is just Middletown. So we don't need the previous Excel anymore. Let's save it and let's open this new file. It's called Middletown. We already have a model here, so we don't have to build our model from scratch. So let's open the file Middletown. So it's under chapter 10.
I'm stuck here for like 10 minutes. It won't let me. Like, I just entered that in to try to catch up, and obviously it's formulas. So whenever I did the data table, it just dropped all the same numbers, and I can't get it to go away.
What? So you are
That's exactly what I wanted to do. That's not right.
On this one, if you want to do the two-way analysis,
Yeah, but see, I was just thinking these numbers, you can't like that.
price, column is the quantity. Oh, I didn't see that.
So we did that, and just did 2,400. Because I think it's because I just entered those numbers, trying to put those.
So how about let's fix this one. Okay, after you have this one, so it's about an amusement park. So it's just like adventure. So for admission, there are two types of things. One is a seasonal pass. The other is just one-day admission. So they gave us some data. Admission price, if you do not have the seasonal pass, the price for one-day admission is $35. And they expect the number of seasonal pass holders admitted is 3,000 people. And also we have some admissions, so we would expect 1,600 people will purchase one-day admission tickets to get into there. And we have some average revenue from each type of the customers. So for the seasonal pass holders, so normally every people will spend like $15 in the park, and for one-day admission customers, normally they will spend like $45 per person. And cost of operations, the daily operation cost is 33,000, and the cost of goods. So when they purchase food in the park, they purchase some souvenirs and so on and so forth. So its cost is 50% of the sale price. Then they want to calculate some revenue, and eventually they will want to calculate the profit. So we have the different revenues, we add up them together, we have the total revenue, and we also have the cost of operations and goods, and we have the total cost, and then we have the profit. So that's the whole story of the park. But the problem is, we know that the number of people who go to the park really depend on the weather. So if it's raining, probably not so many people will go there. But if the weather is really great, more people will go there. So when they do the calculation, when they estimate the profit, they have to consider different scenarios. What if it's a rainy day? What if it's a sunny day? What if it's a cloudy day, and so on and so forth? Then they have to use those scenarios to analyze. What if it's raining? What's going to be my expected profit? What if we have a sunny day? What is the profit? Then we have to define some scenario. So this is the data we are given here. So we have three scenarios. If it is partly cloudy, so we have different numbers. So seasonal pass holders 3,000. That set of number are in the spreadsheet. So they assume that. So that's the most popular scenario. And what if it's raining? We still have some people go there. So when I go to Disney World or Universal Orlando, although it's raining, I see a lot of people go there. But it does affect the number of people go there. So if it's raining, the seasonal pass holders will be reduced from 3,000 to 12,000. And then we have different numbers. Admissions will only 250 and so on. And if the weather is really great, we would expect 8,000 seasonal pass holders will go there and so on and so forth. Then we have different values. So 1, 2, 3, 4, 5 variables. So that's why we have to use this scenario manager to define scenarios and then calculate our profit. So let's see how we can use this scenario. Let's see, scenario. What if analysis? Scenario manager. Yeah. Okay. So you go to the data tab, what if analysis, and then there's function called scenario manager. Then we have to define those scenarios. So partly cloudy, so let's add the first scenario. So partly cloudy, so let's do that. And so the name, let's just copy the name. Partly cloudy. I think it's a changing cells. What values are we going to change? We are going to change the number of seasonal pass holders. So that would be B6 in the cell B6, and the second one is the number of admissions B7, average expenditure 8, and average expenditure from the admission, one-day admission customers, and one more is cost of operation. Also, we may shut down some of the activities if it's raining. So select B6 through B9 and B11. Because we are gonna change those 5 values. me show you how to do the selection. Everything. Like this one, I just select B6 to B9, and I think comma, and then select B11. Then enter.
And then when you click it, you just hold control, and then you can hold the animation.
Or after selecting the first 4, you press the control button and then select B11. That also works. So after you're done with selection, please click OK. After click OK, you will be asked to enter the values. I think for this one we just use the default value. Let me see. Yes, we just follow the default value, and then you can just click OK. Okay. Now you see the first scenario, partly cloudy. So let's use this method to add the second and third scenario. Please add those 2 scenarios. So the second scenario is green, so let me just add one more. So it's called green. You select the cells, and then change the cells.
It's the same cells.
But we don't have to reselect cells because the selection will not be changed. But the values will be changed. So the seasonal pass holders will be $1,200. The second one is admission, $250. Third one is $10. Next one is $20, and the last one is 27,000. Okay, so I added the second one. Similarly, I added the third one. The best scenario they want to see, sunny, in change value. So you just follow the numbers on the table here.
So I do the last. Oh, I got you.
All the numbers are here. So you already, I think all of you already finished the first one, the first scenario, the second scenario. You just enter those numbers. Then, after you finish the second one, do the third one by using the fourth column. after you have all the scenarios, how about you try to click the show button? Let's see what will happen. So select one scenario and click show. Sunny, show, partly cloudy, show. You will see the numbers are updating based on the scenario. Then the last one you want to see is the summary. So summary report. After playing with those three scenarios, how about you click the summary button there? And then you will have a report. So summary, and I will see, okay, scenario, summary, yes. The result cell is V25. V25 is my profit, yes. I want you to show me the profit based on different scenarios. So that's the report they gave us. So we have three scenarios, and we have the corresponding profit based on the scenario. So that's the original model we have. So let me save this. So that's all we need to know about the scenario manager. So if you want to change more than two variables in your what if analysis, let's use the scenario manager. If you only want to use two, just use the two-way table. Or if you just want to change one quantity, you just use the one-way table. So that's what we did. Report. Okay. So next we will introduce some functions. We are not going to discuss all the functions because we used some of the functions in the previous lectures. So the sum function, the sum product, we already used them in the previous applications, so we are not going to spend time on those two. We will skip that. If and countif, we also used those two functions before. Last class, we used the if function to generate the value of the W variables. So if the quarter is equal to 1, so the quarter 1 variable is equal to 1, otherwise it's equal to 0. And countif, we use that in the previous chapters, so we are going to skip those two. But we are going to study this one. So we look up. So in this one, for this table, for this function, let's open an Excel function called, let's see, granite. So is that the pronunciation? The Granite. So that's an Excel file. Please download. We have the model. We don't have to do anything on this Excel. We just want to explain what the VLOOKUP function is. So the file name is Granite. So that's Excel function. So if you already opened this Excel file, so basically this file tells us the performance of 4 salespersons. So they are selling insurance. So by the end of the year, the manager wants to give some bonus to those 4 salesperson people. So different people have different sale performance. So if we look at this part, the percentage above target sales. So for the first person, so his or that person's the final sale is 83% above the target sale, and the second one is just reached the target, and the third one is doing much better, so it's 118% higher than the target. Okay, so based on this percentage, the manager wants to distribute some bonus. So totally, the bonus pool has $250,000. So this, and then the measure has some criteria. If your percentage above target cell is between 0% and 10%, you will have no bonus point. But if your percentage is between 11% and 50%, you will have 10 points of bonus points. And so forth, we have different categories. So we have 1, 2, 3, 4. I think we have five categories. And then what we need is to calculate the bonus points. So based on the actual performance and the criteria that is given by the manager. So what we want to do is to populate this column using this table and the actual value. So we want to do something like that. We want to put this value into this criteria and see if 80% is falling into the first interval or the second or the third or the fourth and so on and so forth. Then I want the Excel file to return the bonus points, and I want the Excel to populate the bonus point here. So we can manually do this. 83% is in this region, so that first person will get 25 bonus points. We can do that manually, but if we have too many people, it's really time consuming. So that's why we want to use the VLOOKUP function. If you just double click one, or if you just double click the first bonus points, so it will show you the lookup function. So we have 4 inputs. The first one is the value that you wanna look up. So the value here is the B15 is basically is here. It is 3%, and the second input is the table. So you want to look up this number in this table. So and 3, the third input is the column that you the column that you want the value should be returned. So if after the Excel file find this number in some of in this category or in this interval, I want the Excel to return this one. So because this is column 1, column 2, column 3, I want the Excel to return the corresponding value on the third column. So that's all. That's the third input. And true means we have to have an exact match or the first approximate match. So here, if it's true, it's called approximate match. So that's the function we use. Then we use this function for all the people. Then this column will be populated. So that's the application of the VLOOKUP function. So here we don't have to do anything in this file. So that's what we had. Okay, the next one is auditing the spreadsheet model. So when we do some coding, we know business majors do not do a lot of coding, but if you talk with computer engineering or computer science people, they do a lot of coding. So debugging is a major task. But when we build Excel model or spreadsheet model, we also need some kind of debugging. So we have some tools that can help us do the debugging. So the first one we want to look at is the trace precedence or and dependence. So what does that mean? So trace precedence button can tell us what values contribute to the selected cell. So if you put in a formula, so this cell is equal to this cell plus this cell plus this cell times this cell. So if you select this cell and use that function, the Excel file will just point to those different cells that you included in your form. And the second one, the dependence. If you select a cell and you use this function, it will show you where this cell is used. So maybe this cell is used in this formula and also this formula. So the Excel will tell us, okay, so those are the two places where this selected cell is used. So let me just use one of the files. Okay. How about this? Let me just use this one. So where is the data formulas? So enter the formulas tab. Let me click. Let me use this saving. So I select the saving cell. Let me select the precedence. So because the saving is based on the cost, the manufacturing cost and purchasing cost. So if I use that function, it shows me, okay, those two values are used for the saving function. So let me remove the arrows, and then let me demonstrate the other one. I want to know where this outsourcing cost is used. So I click this one. Then it shows me, okay, so the purchasing cost per unit is used for calculating the purchase cost. Okay. In this way, you can, after you enter a formula, you use that function, then you will see, you can check if you missed one value or two values and so on. So that's kind of help us do the debug. So that one, you don't have to open that. Show formulas. I think in one of the previous class we had this problem. When this show formula function was selected, after you enter the function, it doesn't show you the number. It still show you the formula. And show formulas, evaluate formulas, and I think we have error checking and other things. Watch window. So I'm not going to spend time discussing those functions. Please, after class, you spend some time to play with those functions. And the last one is predictive and prescriptive spreadsheet models. So here in this chapter, we talk about what if analysis, building the model, and we use the scenario manager to show different results. But all of them are called prescriptive or predictive or descriptive. So they are called descriptive analytics or descriptive models. Then in the next chapter, chapter 12, we will start to talk about prescriptive models. So the definition of prescriptive models is the model or the analytics have to give us some decisions. So if we do the what if analysis, we just put in the number and see what's going to be the profit or saving. So that's not the best decision we need. So in the next one, we are going to discuss that. But in the previous chapter, when we were talking about regression analysis, when we were talking about forecasting methods, that's kind of predictive. We want to use those methods to predict the future. So that's predictive analysis for the models. And the next chapter, we will talk about optimization. And in the following chapters, we will talk about different types of optimizations. And optimization models will tell us the best decision. So they are going to be called prescriptive analytics. So that's the end of chapter 10, and let's start a new chapter. deal with some decision-making problem when we do the optimization. When we do the optimization, we want to maximize or minimize something. We have an objective. So normally in our business field, we want to optimize or maximize our profit or minimize some risk. So that's our objective. But when we deal with real applications, we have a lot of constraints. For example, we have limited number of resources. If you work on healthcare, if you work with a doctor, doctor has, so every day, how many hours does the doctor have? Maybe 8 hours. So when you do the scheduling, you cannot schedule 100 patients to the doctor for 1 day. So you cannot do that, because the doctor only has 8 hours or 9 hours or 10 hours. Or if you want to send a lot of patients to a hospital, you have to consider how many nurses are there, how many beds are there, and so on and so forth. Those are constraints. So when you do the scheduling, when you do the staffing decision, you have to consider the constraints. Everyone wants to maximize the profit, but everyone has limited number of resources. So that's constraint, and also we have the objective function. And the model, based on the format of the model, the model can be linear or it can be nonlinear. We will talk about both, but in this lecture we will talk about linear optimization. So some of the applications. So a manufacturer wants to develop a production schedule and a inventory policy that will satisfy demand in future periods and at the same time minimize the total production and inventory cost. So we have to, in this description, we have to get two things. One is the decisions. They want to develop a schedule, production schedule and inventory policy. So that's the optimal decisions that they want to get from this optimization model. And their objective is to minimize something, minimize the cost. If you look at the second one, so an investment portfolio, so that's the decision they want to have. And they want to maximize the return. And third one, they want to maximize the effectiveness. And what they want is how to allocate a fixed advertising budget. So I have this amount of money, how do I allocate into different fields so that the effectiveness it will be maximized. And the last one is so that the transportation costs are minimized. So they want to minimize the cost. And they want to know how much each warehouse should ship to each customer. So shipment plan, so that's the decision they want to have. So objective function and the key decisions they want to make. So linear optimization model, so it's called linear programming. So making the better decision, okay, we already discussed that. The real applications, the GE Capital use linear programming to help determine optimal lease structuring, and oil company, Marathon Oil Company wants to use this programming to for gas blending and to evaluate the economics of a new terminal or pipeline. So there are a lot of real applications. So if you look at this company, let me just open this one. So we have this Excel file. I'm not sure if we have enough time to implement the optimization today, but let me briefly talk about this one. So this company is producing golf products. So I think it's producing the bag. So they have two types of products, two types of bags. One is a standard bag, the other one is a deluxe. So two types of products. So by the end of the third year, they can sell all, they assume that they can sell all the products they produce. But the problem is, they have limited number of hours to make the production. So they have So manufacturing each type of the product has 1, 2, 3, 4, 4 operations or 4 processes. So then the first process is to cut and dye the material, and then thawing, finishing, and inspection and packaging. So every product has to go through those 4 procedures. And for each process and for each type of product, they have different hours required in the manufacturing. For the standard products, 0.7 hours is required for the cutting and dyeing process. And for that process, they have limited number of hours. So for that, the first process, they totally have 630 hours. So I don't care how many standard bags or how many deluxe products you want to produce, but that's my capacity, 630. That's my capacity for this process. If you want me to produce 1 million units of standard, okay, that's good, but I don't have the capacity to finish that job. So that's the constraint. And for each process, we have different constraints. In this case, we have different available hours. So that's the production side. And then we have the profit. After we manufacture all the products, we sell those products to the customer, and we have profit. Standard product will give us $10 per unit profit, and deluxe will give me $9 per unit. I don't know why deluxe has a lower profit margin. Anyway, let's just deal with the numbers. Okay? So that's the data we have. Then the manager wants to make some decisions. Given the production constraints, given the production requirements, and the unit profit or profit margin, how many standard products and how many deluxe products do I need to make such that I can maximize my profit? So that's the total profit. I want to maximize this one. And the decisions I want is, so I need 2 numbers. One is the number of standard products, the other is the number of deluxe products. So decisions, my objective. So here my objective is to maximize my profit. But sometimes maybe in your application, if you are operations guy, probably you are going to minimize some, we have like some operations costs. So if you're an operations guy, you may want to minimize some costs. But here in this application, we want to maximize the profit. Okay? So that's our whole problem. So that's the data we have. We just show the data in the Excel. We have production time, standard, deluxe, what else? Okay, available hours, and we have the profits. That's all we have. Then after we have the whole description, after we know what's going on in that company, we want to formulate the problem. We want to put the problem in a model so that we can solve the model and optimize or maximize our profit. So problem formulation or modeling, so that's a process of translating the description that we just did into a mathematical statement. So you cannot type in English into the Excel file and hope that Excel can understand your language and solve the problem. So that's not possible. So we have to translate the English to mathematical formulation. So how do we formulate that? Of course, we have to understand the problem and describe the objective. Do you want to maximize something or do you want to minimize something? Constraint. What is the constraint? What is the available hours for each of the processes? So that's constraint. Or you have limited number of labor hours and so on and so forth. Decision variables. What are the decisions you need? In this case, 2 numbers. Number of standard products, number of deluxe products. Write the write the objective function in the term of decision variable, you have to include decision variables in your objective function so that the program can manipulate different combinations of the decision variables to calculate the objective function and select the best value. And then write constraints in terms of the decision variables. You have to put some constraints in the decision variable. If we do not have constraints on our decision variable, the value could be negative or infinite. We know the number of production or the units to be produced cannot be negative. But Excel doesn't know that. So you have to put some constraints on your decision variable. You have to make sure that your decision variables are non-negative. So those are the constraints we have. So constraint 1, number of hours of cutting and dyeing time used must be less than or equal to the number of hours or the number of available hours for this process. So that's process 1, process 2, 3, and 4. So when Excel is doing the calculation, manipulating the different values of variables, so they have to make sure that the value they try or the value they find will not violate those constraints. So they are not going to try 100 million units for the number of standard values. It's just violating the constraint. Then let's use some notations for the decision variables and other parameters. So decision variables, it's kind of flexible. So normally, when I was taking the optimization classes, I was using x, y, or z, or even z to denote the decision variables. But here, if you put into the Excel, you don't have to use x, y, or z. So you just use the notations that are clear enough for you to catch. So if we want to define the number of standard bags, we just use S to denote the standard. Deluxe, use D. So those notations are the decision variables. How many standard bags, how many deluxe bags we want to produce. So those are decision variables. Then write the objective in terms of the decision variables. So what is the profit? So the profit function is the profit margin times the number of units. So profit per unit for the standard bag is $10 and $9 for the deluxe bag. So the total profit is 10 times the number of standard bags plus 9 times the number of deluxe bags. So that's our objective function. Then in the mathematical form is 10s plus 9 times d. And we have one more term, max. So you need to tell us, are you going to maximize this function or minimize function? That's very important. Okay? You need to tell people you are going to maximize this function. So that's the same variables and our constraints. Objective function. Here are the constraints. So we make one more translation. So constraint 1 hours of cutting and dyeing time used, it should be less than or equal to the available hours. So that's the kind of still English. So in the mathematical form, this is what we have. So 0.7 hours has to be used for producing a standard bag in the first process times 1 hour times producing 1 unit of deluxe bag. And how many available hours we have? 6, 30. And we do this to the first process, second process, third, and fourth. So those are our constraints on the, let's say, on the resources. Then sometimes we may forget this kind of constraints. So non-negativity constraints. We have to make sure our decision variables are non-negative. We have to make sure the decision variables are non-negative. So that's the whole model we need to consider. So if we put all the pieces together in one slide, this is what we have. Objective function, every time you write the model, you have to write your objective function first. Max your objective function, or mean, which means minimize your objective function. So that's the first one you have to write down. Then you need to write down your constraints subject to. So sometimes I use subject to, or sometimes I use ST. So lay out all your constraints, including the non-negativity constraints for the same variable. Then that's the whole optimization model. That's the whole optimization model. And here we have the two distinct variables: number of standard bags and number of deluxe bags to be produced. So any questions on this model? I think this is a relatively simple model. Then how do we solve this model? So we have to determine if some properties of this model. So in this model, linear or non-linear. So this model, that model is a linear model. So it's called linear programming model. So the objective function is linear and the constraints are also linear. So what is linear function? So mathematical function in which each variable appears in a separate term and is in the first power. It's not x squared x to the power of 3. It's just x to the power of 4. Okay? First power. Then that's going to be called linear programming model. Then how to find the model solution? We have to define some feasible solutions, because some solutions are solutions, but they are not feasible. Those standard bags, I want to produce 1 million deluxe, another 1 million. That's a solution, but it's not feasible to us. So we have to find the feasible solution, and we need to search over the feasible region. So when we search the solution, we have to define which region contains the feasible solutions. Infeasible solution or infeasible regions, we don't have to search, we don't have to consider. Then we find the solution that gives the maximum objective function value, or minimize. In the case of minimizing, we will find the smallest one. In this case, we are linear and the line is separated. So because this is a relatively easy model, so when we can plot the feasible region or the solution region. So if constraints are inequalities, the constraint cuts the plane in two. And the line and the area on one side of the line is the space that satisfies the constraint, and we consider that space. And subregions called half space, and those are some terms you can read offline. So that's how we define the feasible region. So if we just have if we only have the objective function. So if we look at this figure, we have two axes. Axis denotes the value of number of standard bags, and vertical axis represents the number of deluxe bags. So if we have no constraints, it can be anywhere. So it can be negative, but since we do have constraints, first of all, those variables have to be positive. So we only select this corner in this whole area because of the distinct variables constraint. Then we have to input those 4 constraints. So we have a line for finishing. So that's a constraint function for finishing. So it's a linear line, and we put the linear line there, and this region is the region that satisfies that constraint. And then we do the same for all those constraints, and we have line, then we say, okay, but only this region is the feasible solution region. And then we will find a solution in this region. Maybe the best solution is here, there. Then we need a method to help us search for the best solution. Okay. And then which method should we use, how the method would work, so we will talk about so I will talk about that in the video. Okay? So that's all we have today, and we don't have class next week. I will post the lecture videos on probably Friday or Saturday. Okay? We don't have any class next week. Okay? So hope everyone will enjoy the whole week.
Hope you do too.
Yes. I will traveling